Okay, we're going to continue 3.4 here. We left off with this polynomial, and we saw that the possible candidates for the roots were plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus a half, and plus or minus 3 halves at the end of the last video. And we want to factor this polynomial, so we simply do a little bit of trial and error. So we try each one. So let's start with the first one. Here we get 2 plus 1 minus 13 plus 6, and that's not 0. F of negative 1, that's negative 2 plus 1 plus 13 plus 6, that's not 0 either. F of 2, well, what do we get? We get 16 plus 4 minus 26 plus 6, and that is 0. That's 26 minus 6, that is 0. So we have, again, one solution. And once we get one solution, one root, then we stop there. Notice, so since 2 is a root, x minus 2 is a factor of f of x. So we do synthetic division. So we say, okay, let f of x be 2x cubed plus x squared minus 13x. We're going to divide by the polynomial x minus 2. And we do, again, using synthetic division, so it's a bit quicker. We put the coefficients of f of x at the top, and we start. So we drop down the 2 here. 2 times 2 is 4. 1 plus 4 is 5. 2 times 5 is 10. We add, we get minus 3. 2 times minus 3 is minus 6. And we end up with 0 here, which we should. If we did end up with 0, then something would be wrong. So this is your remainder. This is your quotient, q of x, which is 2x squared plus 5x minus 3. And so we can write f of x as the product of d of x, which is x minus 2, times the quotient 2x squared plus 5x minus 3. And so the question now boils down to, how do we factor this? And so let's first try direct factorization. How do we, so recall from, I think it's probably one of our preliminary videos here, how would we factor this? So let's just look at this off to the side for the moment. Well, we multiplied 2 and negative 3, that's negative 6. And then on the bottom here we have 5. We need two numbers that multiply to 5 and that add up to minus 6. So minus 5 and minus 1, they multiply. Sorry, the other way. I apologize. We need two numbers that multiply. So we need to multiply to minus 6, and we need to add to 5. So minus, let's see, minus 1 and positive 6, I think works. So those two numbers add up to 5 and multiply to minus 6. So we split 2x squared plus 6x minus x minus 3. We split the 5x into the 6x and minus 1x, which we got from here. And then we factor two terms at a time. So we take out 2x here. We get 2x times x plus 3. And then minus 1 factors out from the second two terms times x plus 3. And we end up with 2x minus 1 times x plus 3. And so f of x then, since we were able to factor that directly, this is x minus 2 times 2x minus 1 times x plus 3. And this is the full factorization of this polynomial. So this is the full factorization, fully factored. Okay, so that is, by the way, a couple of things to note here. What were the other two roots? We had started by getting 2. From this, we would get x equals minus 3, which is also one of the ones we listed. And from this, you would get x equals a half, which is also one of the ones we listed. So all of the roots turned out to be in the list of possible rational roots that we mentioned at the very beginning of this video. So that's an important thing to note, that the thing with which we started, the assumption, it turned out to be true, that all the roots were on that list. Okay, let's do one last example, and that'll be the end of 3.4. There's a couple of topics in the book that I'm not covering, so don't worry about those. So the last example we're going to do is a quadratic polynomial, or a 4th degree polynomial. Sorry, not a quadratic, but a 4th degree polynomial. So x to the 4th minus 2x cubed minus 2x squared minus 2x minus 3. And here note that the lead coefficient is 1. So in fact, all the roots, well, we'll do it fully, but all the roots will be factors of -3. Whenever the lead term here is 1, and we saw that kind of in the very first example, then all the roots will just be factors of this last term. But let's just do it the long way. P would be all factors of -3, the numerators, so plus or minus 1, plus or minus 3. Those are the only integer factors. And then for the denominator, we would want all factors of 1, which would be plus or minus 1. So in this case, P over Q turns out to be plus or minus 1 and plus or minus 3. Because remember, when we're dividing by plus or minus 1, it doesn't change the number in the numerator. Possibly by a negative sign, but we've already listed all of the signs here. So we end up with exactly what we have. This and this are exactly the same. And that's always the case when we have that lead term as 1. Okay, so let's check these, because there's not that many to check. We should be able to get one quickly. F of 1, that's 1 minus 2 minus 2 minus 2 minus 3, and that's definitely not 0. F of minus 1, what do we get? We get x to the 4th is a positive 1, and then we have x cubed, so minus 1 times minus 2 would be plus 2, and then minus 2x squared, we have minus 1 squared, so we get minus 2 here, and then we have a plus 2 here, and a minus 3. So this 2 and this -2 cancel, and we get 3 minus 3, which is 0. So -1 works. So -1 is a root, which means x minus minus 1, or x plus 1, is a factor of f of x. So again, let me just rewrite f of x here. So it's x to the 4th minus 2x cubed minus 2x squared minus 2x minus 3. So we're going to do synthetic division with c. So we're going to use c here, which is our root, -1. We're going to put that next to the coefficients of f. So 1, minus 2, minus 2, minus 2, and minus 3. So we drop down the first term. -1 times 1 is -1. We get minus 3 here. -1 times -3 gives me a positive 3. Add those, you get a positive 1. -1 times 1 is -1. Multiply those, you get 3. -1 times 3, oops, get -3 here. -1 times -3 is positive 3, which lands us with a 0 here. Okay, so what we have then is f of x is equal to x plus 1, the d of x. And remember, this was a 4th degree term. This was a cubic. This was x squared, x, and the constant term. So it's 1 less. This is a cubic term. This is a square term. This is x. This is constant. So we get 1x cubed. Oops, let me switch back to white. We get x cubed minus 3x squared plus x minus 3. And so what can we do here? Well, the question is, can we factor? So the question now is, can we factor this? Can we factor directly? Now, in this particular case, it actually turns out that we can. It is possible to use the rational root theorem again and find more factors, but I'm going to show you how to factor this one. And this method, again, doesn't work always, but it does work in this case. So in general here, we can apply the rational root theorem to this polynomial q of x that we got and proceed almost like it's a new problem to this one. But it turns out in this case we can actually factor directly. So let's just go ahead and factor directly. And the method here is factoring by kind of grouping two terms at a time. So we're going to group the first two terms and group the second two terms. And what we end up with is we can factor out x squared on the first two terms. We get x minus 3. And here there's nothing in common, but we can always factor out a 1. And then we also have an x minus 3 here. So this is x minus 3 times x squared plus 1. And so we have actually factored now this second part. So overall, remember that f of x was x plus 1 times this polynomial, x cubed minus 3x squared plus x minus 3. And now we have factored that as well to get x plus 1 times x minus 3 times x squared plus 1. Okay, now the question is this fully factored? Because technically now we still have this term right here. But it turns out this is not factorable. This is not factorable. And I think I mentioned something about this maybe in one of the first videos. But if you have a positive, well, there's multiple ways to see this. Let's apply the quadratic formula, just to be kosher. So let's take x. We have x squared plus 0x plus 1. That's what this is. So we have a is equal to 1, b is equal to 0, and c is also 1. So we have negative b plus or minus square root of b squared minus 4ac divided by 2a. These are the roots. So this is 0 plus or minus the square root of negative 4 divided by 2. And you can see here that you have a square root of a negative. This is not a real number. And you can only factor something if it has real roots. This has no real roots, so hence this is not factorable. Okay? And in general, I'll just state this as a fact here off to the side. So if you're given ax squared plus b, where a and b are both positive, then this is not factorable. You can remove a constant out of it. You can remove a number, but you can't make it a product of two lower degree polynomials. So this is actually the final answer here, which I boxed in red. That's the final factorization, and that concludes that particular example. By the way, in the book, there's some examples where they do this and then they graph the polynomial. You can do that as well. That's something we've already covered, so I'm not really focusing on that right now. Okay, this is the end of 3.4, we'll start 3.5.